Hi everyone. In this video, we're going to get started learning about scikit-learn, SKLearn, and we're going to do that by building a k-nearest neighbor classifier that works with congressional voting data. Before we get started doing that, I just want to remind people if there is an associated notebook, it's this one. It's the Intro to SKLearn notebook that's available on GitHub, and we've already seen examples of how to load that Jupyter notebook from GitHub into Colab, into Google Colab. So I don't need to do that now. I just wanted to point out that there is this associated notebook so you can practice these skills on your own and just get a little bit stronger in understanding how this works. Okay, with that in mind, let's go back to the notebook. So the data set is the 1984 congressional votes. It's labeled data, meaning that what we're trying to do is decide whether someone's Democrat or Republican based on how they voted for 16 different bills. So as part of the data, we have whether they're Democrat or Republican, and that's what we're trying to learn. We're trying to make that prediction based on how they voted for this handicapped infants bill, the water project cost sharing bill, and so on. So the first thing we want to do is import the library, the pandas library, because we're going to be creating a data frame with this data. So let me go ahead and do that by hitting that shift return that we've looked at before. And now the data set has the first column of the data set does not contain the column names. It's just really the first row of the data itself. So we need to create those column names. And that's what I've done here. I've just simply created a little Python list with the names of the different columns. I've kind of abbreviated a lot because Export Administration Act South Africa is sort of long, so I just abbreviated it to South Africa Exports. But you get the idea that I'm just putting labels so they're somewhat meaningful into the data frame. So let me go ahead and do that. So here, when I did the length of how many there are 17, and that meshes nicely with that there's 17 columns in the original data. So we're good to go there. So now I have this column names that represents the names of the columns. That's obvious. I'm just changing the order of these words. All right. So with that in mind, let's go ahead and read the data. So this data is available here at this thing. Let me just grab that. And we sort of know how to do this already, hopefully. So I'm just going to call it votes. Sorry. And that's the data set. And as I said, it doesn't have the names of the columns. So I'm going to add that. And I'll just take a look at what that looks like by going votes. There we have it. It's a very small data set, 232 rows representing the people that voted for all those bills. I think we don't have any missing data. So there are 232 people, and we're recording their votes. Okay, very often, and so far we've seen that the data was provided to us with a CSV file. Let me go back up and see that. So here's the CSV, and that means, again, comma separated value. So that's pretty easy to do. We've done it now a number of times. Sometimes the data isn't provided to us that way. One way things might be provided to us is in a compressed format, in a compressed file like a zip file. So that zip file might contain the comma separated value file of the data, and it may also contain a little README or write-up of how this data, a more description of the data. So let's see how that would work. So if we got a zip file, how we could use it. So for this, we're going to use the Linux commands we've seen. And as I mentioned before, we start a Linux command, or we say, hey, this is a command executing by the operating system with this exclamation point, or I call it bang. And I'm going to use wget, so that gets some file remotely and puts it on makes a copy onto our local computer, in this case, that virtual machine running Google Colab. And I'm just going to make this a little easier for me and just paste in that original address. It's not votes2csv anymore. It's votes.zip. Whoop, I can't type. Zip. So that's a zip file, and I'm getting it locally. All right, so hopefully we have that file, and just to check, let me do the Linux command ls for list. It'll show me what's in that directory. And here we see we have that zip file, housevotes.zip. Now what we need to do is unzip it. We uncompress it, so I can issue this unzip command. It's a Linux command, not one that Python knows. I'm going to unzip that. And it says it did. Let's just take a look if it in fact did by doing another ls. Sorry. And now we see we have that CSV file, which I can now load. So let's go ahead and do that. Let's call it votes2 because we already created a votes. PD read CSV. So this time, instead of giving a web address, I'm going to just give that local file, housevotes2.csv. Whoop. Okay, and let's just make sure it's there. Okay, and it's the same thing. So that was just kind of a little aside, just showing what happens if we don't get the data always in CSV, but in another form. And in the one we just covered, the form was a zip file. So we can use wget and a variety of other Linux commands to get that there and unzip it. All right, so back to the original task. So we have votes. Let me just check that. And that's this 232 rows of how people voted. Yes is 1, no is 0. And so we have handicapped infants and see how people voted. So a lot of Democrats voted for that, and one Republican voted no, another one voted no, and so on. Sweet. Now what we want to do is divide it into a training set and a test set. SKLearn has a utility that allows us to do that. And so we do this by the following: SKLearn and as you can guess, train test split, just guessing by the name, is going to divide a data set into a training set and a test set. So I'll show you how that works. So it's going to return two things, two data frames. One's a training data frame, or the votes.train, and the other one we'll call test. And we're going to use that function that we just loaded in. Whoop. And one argument is what we're splitting. In this case, we're splitting the votes. And the other argument is, well, what percentage do we want in the test set? So let's just say we want 20% of the data to be put in the test set. So that's how we read that. And let's just do a sanity check by looking at votes.test. So there was 232 rows. So there should probably be somewhere 40-ish or so, 20% in this test set. And I made a mistake. Oh, yeah. Okay. I missed the L for model. Sorry, let's give that a shot. All right, there we go. So now we have this divided up into a training set and a test set. 20% in test. The rest is in the training set. Cool. We also mentioned before that we need in order to do the fit, we need the features. It's nice to have the features separate from the labels. And let's go ahead and do that. So now we have two data frames, well, 3 if we count votes. But we have votes train and votes test. So we split this votes up. And now we're going to split each of these into the features of votes train and the labels of votes train. So we're going to create 2 data structures for votes train and 2 for votes test. That will look like this. Let me get to the bottom here. Okay, so let's go ahead and do that. So we had this Python list already called column names and the list of columns, and we could use that. That would be the sensible thing. But I'd like to show you another way that might be useful if you have a lot of columns in a data and the columns already have names provided. So let me show you how that would work. So I'm going to create a structure called fcolumns. It's going to be a Python list consisting of all the columns in the votes data frame. Let's just look at that. Okay, so it's what we had before, but this is a useful exercise. So now we'll want to remove the label from the data. And that label is this party column. So I'm going to put party here. So we've removed that label. All that remains now are the features. And now finally we can go ahead and divide up both votes train and votes test. So let's start with votes train. So I'm going to create just the features of votes train. Whoop. I'll get it eventually. And that'll be the F columns, right? So all those columns other than party. And let's do the same thing with votes test. Okay, so now we have the features extracted, and now let's get just the labels by themselves. So the obvious name for that would be votes train labels. And the name of that column is party. Right, we want to predict whether the person's Democrat or Republican. And I'm going to do the same for votes test. And let's just, for a sanity check, let's just pick one and take a look at it. Let's say it's going to be votes test features. And there we have it. So we're hopefully having all the columns, other than the party column. All right, so that's good. So you can see that even with good, clean data, there's a little bit of preparation involved before we actually get to the machine learning component of what we're trying to do. Okay. Okay, and finally now we can build a Euclidean k-nearest neighbor classifier with k equals 3. The first thing we need to do is import the associated library. So from SKLearn.neighbors, import kNeighbors classifier. So there it is from sklearn.neighbors. We're going to import that classifier. Once we import the classifier, we can create an instance of it. Sorry. And we're going to specify k equals 3 in the sklearn version. The parameter is called nNeighbors equals 3. Now we said we wanted a Euclidean classifier, but the default from the sklearn library is Euclidean. And now we can ask that classifier we just built, what are your parameters? What are your settings? So let's go ahead and do that. And here's all the settings of that Euclidean classifier. So let's start with the ones we should know already. So we have the number of neighbors equals 3. So we set that. The default is 5. The metric used is Minkowski. We covered that before, where a p, the power value is 2. So Minkowski with power of 2 is Euclidean. The Minkowski with power 1 would be Manhattan. Weights uniform means that if we have 3 nearest neighbors, as an example, they all get a uniform vote. So if they all say Democrat, or if 2 of them say Democrat and 1 says Republican, the Democrat choice would win. That's what uniform means. Another option would be, let's do it proportional to how close they are to the thing we're looking at. So if the Republican one is a lot closer in distance, that one might get more weight than the other two. The algorithm up here, where it says auto, there are 3 different algorithms for, well, there are probably more than that. But there are 3 basic kNN algorithms. One is called brute, which is kind of the brute force version of the k-nearest neighbor classifier, and it's the one we covered earlier, right? It just looks, when it's trying to make a prediction, it just looks through all the examples to try to find the nearest neighbors. There are 2 others, one called KD tree and one called ball tree, and what those do are in different ways is create a binary search tree. So when you're trying to find the closest, it's going through this binary search tree. It makes things go a little faster in the prediction phase. It's a little slower in the training phase because it needs to build that binary tree. It doesn't build the binary tree all the way down to one instance in a leaf. It just goes a certain distance until there's a certain size left over, and that's called this leaf size. So at the bottom of the binary tree, there'll be 30 instances at the most in each leaf. And that will be searched for and determine the distance. So that's what these mean. I think I covered most of them. So we'll go with that. So sorry for that long explanation of get params. This is an intro video. I didn't want to get into the weeds too much, but I hope that was a little helpful in explaining what we're seeing here. All right, so the next thing we need to do is fit the classifier to the training set. So in our case with k-nearest neighbors algorithm, it just remembers the data in the training set. One thing I failed to mention, let me just briefly go up. I mentioned that there were 3 algorithms. Auto simply means let the k-nearest neighbor classifier itself determine which of the 3 algorithms to use. So auto says, I'm not going to decide, you do it for me. The other options were, I could have put the word brute here, KD tree, or ball _ tree. So those were the options there. Sorry, I didn't describe what auto meant. All right, so fitting the classifier. So kNN was the name of our instance. So I'm going to use the word fit for training. And now we give it the training data. So that was votes _ train _ features. And we have votes _ train _ labels, right? So it's trying to learn this association between those 2. Okay, and hopefully it did learn that. So fit the data. In the k-nearest neighbor case, it just remembers it, but we have this trained classifier. And now we can use it to make predictions. So I'm going to give it that test set we created. So I'm going to just create a new list, predictions equal, and I'm going to say, hey, predict what votes dot test dot features or _ features. Predict all those values, whether they're Democrat or Republican, based on how they vote. And if we look there, we'll see that this is how the algorithm determined. The first person in the row in the test set was Democrat, Republican, Democrat, Republican, and so on. Looks like it kind of alternates there for a while. So now we're interested in getting the accuracy. How accurate was our algorithm? It's a pretty simple algorithm. Maybe it'll be accurate. Who knows? Maybe those votes are so, specific to Republicans and Democrats that it's a pretty easy task. We just don't know. All right. And fortunately, SKLearn offers us a utility that determines accuracy. And let's just grab that one from SKLearn. And this one's called accuracy score. And what accuracy score will do will be what its name suggests. It'll give us that accuracy. So it takes 2 arguments, accuracy score. It takes the true values, the correct labels. In our case, it would be votes. Whoops. And our predictions. And it'll give us the accuracy. So our algorithm was about 92% correct. 91, sorry, I was kind of being more hopeful. 91.4% correct in deciding whether someone's Democrat or Republican based on those features of how they voted. Now we can kind of experiment around a bit. Well, what happens if we try Manhattan distance? What would that be like? Would that be any difference? So let's create a k-nearest neighbor classifier that's Manhattan. I just changed the name there. and create it here. So we want the number of neighbors to be 3 still, and we're going to set P, which is that power attribute, to be 1. That'll make it Manhattan. And let me just forge ahead here, so we'll fit it to the data. And that was votes. And finally, we'll make predictions. And then we'll get that accuracy score. And I made a mistake. I used fit twice there. Sorry, in my haste, I kind of screwed up. It should be predict. And we get this. This looks like the exact same. So we can continue this. What about if we just tried with 1 vote, immigration, and see how that works? So for that, I'm going to be lazy here and copy this. Probably the bad way to go. I'll call it kNN. I'll stick with Euclidean. And instead of this, all the features, I'm going to train with just the immigration one. Okay, that looks good. And then I need to change this. So I'm just looking at 1 feature here. Okay, I think that, oops, I got to get rid of these M's. Okay, I think that looks good. I probably made a mistake. Well, let's try. Okay, and that worked, but the accuracy was pretty bad. It was sort of like chance in that we were only 55% accurate. So apparently immigration wasn't a big divisive issue back then. Let's try this aid to Nicaraguan Contras. And for just ease of typing, I'm just going to make the change up here. I think it should be aid to Nicaraguan Contras. So can we predict if they're Democrat or Republican, just looking at how they voted on aid to Nicaraguan Contras? What do you think? Is it better than immigration? I don't know. And it is, so we're able to do a better job predicting. One thing we might look at is, well, was it the Republicans or the Democrats that kind of skewed this? Where did we make our error? And for that, we can import actually something else. I'm getting a little out of order here in what that looks like. But we can import another method. So we're going to look at a confusion matrix, and I can say, give me the confusion matrix for the correct labels, votes, test, labels, and then our predictions. And as usual, I made a little typo here. So here in our test set, we can see that about 22 people, they're Democrats, voted against aid to Nicaraguan Contras, and 4 voted for it. And this is the Republican side, where 2 voted against the aid and 19 voted for it. So we can kind of help take a look at what the data represented. The last thing we can look at is, well, what about if we change how many neighbors we use? This k = 5, does that help? And I guess I'm not going to do my copy and pasting because that would take longer. So let's just create one from scratch. And we could say n neighbors equal 5, but k equals 5 is the default, so I don't need to do really anything here. Let's fit that. Trying to type accurately here. All right, so here's the moment of truth. Is it going to be better or the same or worse? And of course, I screwed up here, features. Yeah, typing fast doesn't always work. So we got worse performance when k is 5 compared to k is 3. When k equals 3, way up, we were getting like 91.5% accurate, and now it jumped down to 89. So we played around with what's called hyperparameters. So anything we set or that's set by default when we create the classifier. So here it was a Euclidean distance because that's the default, and k equals 5. Those are called hyperparameters, things we can adjust. So that's all. I just wanted to kind of cover the basics of how to get started with SKLearn using a very simple algorithm, a k-nearest neighbor algorithm. I hope this was helpful. Don't forget to do that Python Jupyter notebook that's available on the GitHub repository. Thanks so much for watching. Take care. Bye.